Hi, this is Shuaijing in Hong Kong PolyU. We will introduce our work about mobile HDR imaging.
Since the lack of mobile HDR image dataset and solution, we established a paired LDR HDR image dataset in image domain by using mobile phone cameras in this work. We capture images under different exposures and lighting conditions, including indoor, outdoor, daytime, and nighttime scenes. Our dataset is composed of a total of 281 scenes in 4K resolution. Both noisy areas and large overexposed areas in the reference frame rely on information from other frames to restore details. We therefore propose a transformer-based network with a novel pyramid cross-attention alignment module to aggregate and align the correlated features, achieving denoising and HDR reconstruction jointly. An effective alignment module is essential for avoiding ghosting artifacts and enhancing details. We design a pyramid cross-attention module to implicitly align and fuse input features. High dynamic range HDR imaging aims to restore lost details in dark and bright regions under challenging lighting conditions caused by limited dynamic range of image sensors. It's common to fuse a stack of LDR frames with different exposure to obtain an HDR image. So why we established this mobile HDR dataset? Actually, smaller sensor size and fewer recording bits in mobile phones results in larger overexposed areas in reference frame, which are more prone to ghosting in HDR fusion. And smaller aperture and sensor size in mobile phones bring stronger noise into captured image, even for the normally exposed area, affecting the final image quality. So mobile HDR image is more challenging. But there is a lack of paired real-world HDR datasets taken by mobile phones to facilitate research on HDR imaging for mobile phones. We will introduce how to generate paired dataset and the statistics of dataset here. In order to obtain high-quality ground truth of HDR images, we first collect noise-free LDR images under each exposure by multi-frame averaging, and then synthesize the ground truth HDR image by fusing the generated clean LDR frames. For dynamic scenes with object motion, we first capture multiple exposed frames from static scenes to synthesize the ground truth HDR images, and then replace the non-reference frames with the images captured in dynamic scenes as input. We establish this dataset in image domain by using 3 mobile phone cameras. We capture images under different exposures and lighting conditions, including indoor, outdoor, daytime, and nighttime scenes as the sample shown here. Our dataset is composed of 3 subsets. Finally, a total of 281 scenes in 4K resolution are included. Owing to the challenges mentioned before, both noisy areas and large overexposed areas in the reference frame rely on information from other frames to restore details. We therefore propose a transformer-based network with a novel pyramid cross-attention alignment module to aggregate and align the correlated features, achieving denoising and HDR reconstruction jointly, namely joint HDR-DN. An effective alignment module is essential for avoiding ghosting artifacts and enhancing details. We design a pyramid cross-attention module to implicitly align and fuse input features. The cross-attention operation enables searching and aggregating highly correlated features from different frames. The pyramid structure and attention transfer mechanism facilitates reliable feature alignment under severe noise, large overexposure, and large motion. We retrained existing HDR models on our train set and compare them with our joint HDR-DN. From the quantitative comparison, it can be observed that transformer-based algorithms outperform CNN-based methods, while our proposed joint DN surpasses the transformer, which is the previous state-of-the-art, by up to 0.38 decibel and 0.95 decibel in terms of PSNR-mu and PSNRL in raw domain. And for the visual comparison, it can be seen that our method achieves significantly better visual results. On the reference frames which have high exposure or severe noise, our method can recover fine details without introducing much artifacts. More cases can refer to our supplementary in order to validate the effectiveness of our proposed module and datasets. We design ablation studies about them. We replace our pyramid cross-attention alignment module with other attention feature extractor adopted by Vector Transformer and AutoNet as the baseline. The performance drops by 0.51 dB, demonstrating the effectiveness of our proposed alignment module. Furthermore, we try to utilize existing HDR dataset captured by DSLR cameras for training. It can be observed the test results remains the noise and ghost artifacts. So the new dataset and solution are demanded for mobile HDR imaging. In summary, we developed the first HDR image dataset by using mobile phone cameras, namely Mobile HDR dataset. It contains paired LDR HDR images in the raw image domain, covering both daytime and nighttime scenes with different noise levels. Furthermore, we propose a transformer-based model with a novel pyramid cross-attention alignment module to aggregate highly correlated features from different exposure frames to perform joint HDR denoising and fusion. Thanks for your watching.